All right, so a rectangular equation is y in terms of x, which is what you've always done. It's just no one ever sat you down and told you that that was called rectangular. But it is y in terms of x. You have y equals and then a statement with x's in it. Parametric equations mean that both x and y are in terms of a parameter t. You have x of t and you have y of t. Do you remember when we did related rates and everything was with respect to time? It's that. Remember we had dv dt for rate of change of volume and then dh dt for height, and every single variable is with respect to time. That's like what that is, right? To eliminate the parameter, like if you want to change it into a rectangular equation, you are going to solve for t in one equation and substitute into the other, which is just a lot of algebra. Remember, that's what it always comes down to, is like doing algebraic steps. Yes, they're both in terms of t. That's another good way to think of it. All right. So what we're going to do is we're going to draw a graph of the following function showing, well, I guess I shouldn't say functions. That's actually bad. I should have said equations because they most of the time do not pass the vertical line test. So I'm sorry. Let's say equations instead of functions. Sorry, I'm so used to writing function, but these a lot of times aren't a function. Showing the orientation, they are directional. But you'll see once I can't really explain that until I have a picture, but you have to say what direction it goes, right? And then we're going to eliminate the parameter. All right, so here's what we're going to do for this one. We are going to make a table. And normally you have an x, y table. It's just t, x, and y. And we were given values to start and end with for t. What are our values we're going to stay in between for t? Yeah, do you guys see that right there? Like, that's given, right? So I'm going to do -2, -1, 0, 1, 2, 3. And we're just going to plug them in. Now you can go point by point, or you can do the whole X row and then the whole Y row. It doesn't really matter. And sometimes it's better to do it one way and sometimes it's better to do the other. It doesn't really matter. You just have to fill it all in. Let's do all the X's for this one. If you plug in -2, what do you get? So 0, good. If you plug in -1 or -3, there we go. If we plug in 0, -4, 1 gives you -3, 2 gives you 0, and 3 gives you 5. Perfect. Easy peasy. Now we're going to do the same thing for y. If you plug in -2, you get -1. If you plug in -1, -1/2, 0 give you 0. And then we have +1/2, +1, and 3/2. So draw yourself a little grid down here. When you graph it, you will only graph the X's and the Y's. So you have to try not to look at this T row. Do you get what I'm saying? Like T was the parameter, but we're just going to graph coordinates X and Y. Right, so our first coordinate point is 0, -1. Again, just don't try not to look at the T row. We're just looking at it. 0, -1. That's where it starts, and it's directional. All right, I'll draw in the arrows once we get the whole graph. So 0, -1, and we've got -3, -1/2, and then -4, 0, -3, +1/2. 0, 1, and then 5, 3/2. So here's the direction. So watch me do this. Or I'll wait till you're because if you look away, you're gonna miss it. We started at 0, -1, so we started right here and it went this way. So you have to put in little arrows showing the direction that it goes. How many do you have to put? I put at least one in between each point, but it starts here and goes this way. That sit well with everybody? Are we all okay? Okay. Now we're going to eliminate the parameter. Which one of these would it be easier to solve for t in? Because you can do it either way, but there's going to be an easy way and a hard way. To get t by itself. Yeah, definitely this one. How would you get t by itself? Yeah, multiply by 2. So you get 2y equals t. This is just a whole bunch of algebra. So you're going to take that 2y, plug it in for t in the other equation. So that's going to give you x equals 2y squared minus 4. And so that'll be x equals 4y squared minus 4. And then you also need to put what values to stay in between. Like, see how t was in between -2 and 3? This is, well, I guess I wrote y in terms of x. I guess it could also be x in terms of y. It doesn't really matter. As long as you have an x and a y. This is x in terms of y. So we have to say what values y is going to stay in between. You can either look at the table or look at the graph. Y is going to stay in between what two values? Yep, -1 and 3/2. And does it make sense that this matches this equation, x equals with a y squared? It's a sideways parabola, just part of it. Okay, let me show you how to do this on the calculator because this is super cool. All right, you're all going to go to mode, which is right here. It's next to the second key. You guys see that? Okay, so go to mode. Do you see how right now function is highlighted? Do you see right next to it says PAR? That's parametric. Go down and change yourself into parametric mode. Did you all find that? Okay. Go to parametric mode. Now you're going to go to y equals. And it gives you x of t and y of t. Do you see this variable key, this x, t, theta, n? Do you ever wonder why it had all those other things besides x on there? It's because when you hit it now, it's going to give you a t. Do you guys see that? Isn't that cool? It geeks me out. Anyway, so x of t was what? T squared minus 4. So put in t squared minus 4, but when you hit the x button, it gives you t because it's the variable key. And then y, and don't hit graph, we need to look at the window first. Y is t over 2. T is the parameter that x and y are both in terms of. And t is kind of an arbitrary letter. They use t usually, but I mean, it could be LMNOP. Do you know what I mean? Like, it's both x and y are in terms of something else. Again, the way I relate it in my mind is to related rates, like where everything was in terms of time. Every variable is in terms of this other parameter. All right, so go to window. Now what were our t values? -2 to 3. So make your t minimum -2, maximum 3. You want the t step to be very, very small so that it puts more t value, like it makes it look smoother if you have that really small. So make that 0.1. That's just usually what I keep it at. And then everything else, like the x's and y's, you can make -10 to 10. Oh, that is weird. Mine's -10 to 10 because I mean, I've used this before. And then the scale should be 1, and then -10 to 10 scale of 1. Can you guys just look here again real quick when I hit graph? I know you're going to see it on yours, but watch the direction it graphs it in. Look. Do you see how it did it in the orientation that it is? Okay. Isn't that cool? It's cool. It's neat. It keeps me up. All right, let's try another one. Or did everyone get that? Or does anyone need me to come look at their calculator? I know the calculator is really fast. No, it's not. Yeah, and I'm sorry, here, let's fix that on the notes. I wrote y in terms of x, but you could say or x in terms of y. I mean, it means that there's an x and a y in terms of each other. They relate to each other, whereas parametric, both of them are in terms of some other parameter t. What were you guys saying about yours? Did it turn out okay? Or? Yeah. Oh, because it was trying to do like, now if you make the t set too large, it'll look real boxy because it'll only just connect. There's another one that it looks good on, or like you can see it well on. I'll show you when we get there. All right, let's try another one. So go ahead and make yourself a table. And it says times are bigger than -1. So that means -1 until forever. So we're going to start with -1. I realize there's not an equal to on there, but we're going to do limits. Okay, we're going to do limit as we go to -1 from the right. We can't go from the left because we want to stay bigger than -1, but still put it on your table. All right. And then we could do 0. And then I'm going to skip to 3. Why would I skip to 3? Look at the equation. Like you can square, like that would be able to square root that easily. Let's do one more value. What would be the next like good one to plug in? 8. And then lastly, we'll do infinity. I realize infinity is not a value. We're going to do a limit as t goes to infinity. But you still want to put it on there so you can see what's happening because this is time. I call it time. It's not really time. It's a parameter t. But t goes on forever. So we're going to do a limit. All right. So limit as t goes to -1 from the right, and then copy over the x equation. This is a nice little review of limits that we're going to do here. If you plug in -1, you are going to get 1/0. I will obviously remind you because it's like my job, but this is back from unit 1. It's been a minute. Okay, does anyone remember what you do at that point or what that means? You're going to look at the sign. It means there's a vertical asymptote. It's either going up or going down. Okay, you would pick a number to the right of -1, like 0, and plug it in and see what sign you get. If you plug 0, it will be positive. And so this goes to positive infinity. Again, I realize infinity is not a number. Just go with it. When it's 0/0, you might need to rationalize or do algebra or factor until, or L'Hopital's rule. Yeah, I feel like that's the go-to. Like that's just easier than all the algebra. Yeah. All right, limit as t goes to -1 from the right, and then copy over the y equation. So if you plug -1 into that one, you get -1/0. And so again, we're just going to test the direction. If you pick a number to the right of -1, like 0, if you and you only need to check the denominator. If you plug in 0 to the denominator, 0 plus 1 is positive, but you have a negative over a positive, so that one goes to -infinity. All right, now these ones we don't have to do limits. We can actually just plug in the numbers. So let's plug in 0. If you plug in 0 to x, what do you get? You get 1/1, which would be 1. If you plug in 0 to y, you're going to get 0. All right, let's do 3. If you plug in 3 here, let's see, that would be square root of 4, which would be 2. So it's 3/2. Oh, no, wait, I'm sorry. 1/2. That numerator is 1. I apologize. Sorry. 1/2. This is the one where the variable's in the numerator. Sorry, I'm confusing them with each other. All right, let's plug 3 into this one. That would be 3/3 plus 1, so 3/4. All right, and then let's do 8. 8 plus 1 is 9. Square root of 9 is 3, so 1/3. And if you plug in 8 here, it would be 8/9. So you're getting really, really close to 1. Now for infinity, again, we're going to have to do limits. So limit as t goes to infinity of the x equation. I love that we're reviewing limits. This is so good. Well, because this didn't, well, for two reasons. First of all, there wasn't an equal to, so technically you're not allowed to just plug it in. But also because there was an asymptote there, so you had to do a limit. So as t gets astronomically large, you get like 1 over a gazillion. So this is going to come out to be what? 0. Good. If t is in the denominator and t gets very, very, very large, you get like 1 over a billion. That's going to be 0. All right. And then last limit. Limit as t goes to infinity of the y equation. What is that one going to come out to? Good. Do you see how they're both t? When it's a tie, you use the leading coefficient. So 1 over 1 would be 1. Okay, we got through that. You all survived. Let's go ahead and draw a picture. Because these numbers are so small, like spread this out a little bit. Like don't put your tick marks super close to each other because we're going to have to look at really small numbers, like the fractions in there. So don't make your graph super tiny. So starting off, x is going to positive infinity, that's this direction. Y is going to negative infinity, that's this direction. So it's going to start off like down here in the 4th quadrant. You see what I'm saying? I don't know exactly where to put a point, but it's going to be down here versus like up here. So we're starting down here somewhere. And then we've got 1, 0. And then a half, 3/4 would be like, I don't know, like right about there. And then 1/3, 8/9. 8/9 is super close to 1. And then 0, 1, you need an open circle there because remember that was limit as t went to infinity. Like you're never going to actually get to infinity. So we do need an open circle there. So it's going to look like this, but your orientation is that it goes this way. I know that that's like uncomfortable to get used to at first because like don't you usually put an arrow on the end like that, but you can't do that. It's going this way. So here, do you want to type it in the calculator and look at it? It'll show you that. Yeah, you can't put an arrow on the end because technically it's going this way. You kind of put the arrows in the middle of the graph instead of on the end. Let's go ahead and type this one in. Go back to y equals, clear that out. And go ahead and type in this one. So for our window, we want t to start at -1. Now it goes -1 forever. Don't make your t maximum like 1,000,000. I know that's tempting, like you want to do that, but don't do that. It like you can't make the t value that big. 10 will be good enough. We go -1 to 10, that will be sufficient. I always leave the step 0.1. As you found out, if you make it too small, it's gonna like give up on you. All right, and then the rest you can leave at -10 to 10. Or you can zoom in on it, I guess, if you want, because this one's a bit smaller. But here, watch me hit graph. Watch the like direction that it graphs it. You see how it started out down here and then, did you see it slow down a little bit? And it's like if you blink, you'll miss it, but it kind of like slowed down. That's because it was like the values are getting closer and closer to each other. Like, you know how we got 1/3, 8/9. If you keep going, it's like they get even smaller. That limit approaches. Okay? Anyway, that's cool. Eliminating the parameter is going to be a little bit tedious for this one because the algebra is going to get like to be a lot, but that's okay. That's healthy for us. We'll get through it. Which one of these is easier to solve for t? It's actually x. I know that there's a square root, but it also only has t once. This one has t twice. So this one's actually easier to solve. You would multiply over the square root. And then divide over the x. And then square it. 1 squared is just 1. So it'll just be 1 over x squared and then subtract 1. That wasn't too bad, right? Survived that, okay? And then you're gonna take that and plug it in for t, right, for both of them in the other equation. This is gonna look messy for a second, but then some stuff's gonna cancel and it's not gonna be too bad, right? So that'll give us y equals 1 over x squared minus 1 over 1 over x squared minus 1 plus 1. So first, what's going to go away? Yeah, minus 1 and plus 1 is gone. And then here's what I would do. We want to get a common denominator up here, like just look at the top part so that we can put that together. So I'm going to rewrite 1 as x squared over x squared. That would be 1. Anything over itself is 1. The reason why is it gives you a common denominator and then you can like combine it together. So it would be 1 minus x squared over x squared. I just combined that together. And then that's all over, what do we have in the denominator? Yeah, 1 over x squared. And then what's going to cancel? Do you see how there's an x squared here and an x squared here? So those are going to cancel out. So you get y equals 1 minus x squared. I realized the algebra was really a lot for that one. But look, does that graph make sense with this? 1 minus x squared. Are you okay? Okay. It's an upside down parabola moved up 1. And then x is staying bigger than what? 0. X is bigger than 0. All right, we're just gonna try one more. This one is trig. You love it. All right, go ahead and set up a table. So t is staying between 0 and 2 pi. We're just going to go around the unit circle. So 0, pi over 2, pi, 3 pi over 2, 2 pi. I'll draw you a unit circle on the board. All right, let's do all the x's first. Right here, cosine of 0. 1. And then what is it, times 3? So 3. Cosine of pi over 2. 0 times 3 will be 0. Cosine of pi, -1, so -3. And then 0, and then 3. Once you get the pattern going, because it's going to be a wave, you can just keep on going. All right, now the y's. Sine of 0. 0. Sine of pi over 2. 1 times 4 is 4. Sine of pi, 0. This will be -4, and then 0. I love trig for that reason. Like, it's very repetitive, which can be kind of boring, but also kind of comforting. It's like, oh, there's just always going to be the same number. Like, kind of nice. So again, ignore the row that says t, just graph the x and the y. So you would have 3, 0, 0, 4, -3, 0, 0, -4, and you get like a, I don't know, like an oval. And then just make sure you put in the orientation. It's like a little egg. It's wherever you start. So you start at 3, 0, and then the next point was 0, 4. Yeah, so it's just the order that this goes in. Do you want to graph that one on the calculator too, or are you good? Yeah, go ahead. I think it's fun. I just think it's cool, like that the calculator will do that. Make sure you're in radian mode. I know it says theta, but when you hit the variable key, it's going to give you t, which is fine. All right, so this will be 3 cosine of t, and then 4 sine of t. And don't forget to change your window. You want the t to be 0 to 2 pi. And everything else you can leave the same. Oh, but this is the one. Here, hold on. Watch for a second. I'll show you what happens. See how I have my t-step as 0.1? So when I graph it, it looks like pretty nice. If you make it larger, like if I make that 1, watch what happens. Like, do you see how it's all boxy? Because it's only giving you a point every t being 1, and then just connecting them. It looks cool. Yeah, it looks like a hexagon. All right, last one. We're going to write parametric equations for this rectangular equation. So, and there's 2 parts of it, part A, part B. So we're going to write the x of t, y of t, given these pieces of information. All right. So for letter A, I made the first one about as easy as you can make it. I made x equal t. All right. So x is going to equal t. That's the x. To get y, you would take t and plug it in for x. And so that would just give you 1 minus t squared. Again, I made that one about as easy as I could. I'm sort of regretting it because that's one of those situations where it's almost so easy that it's like more complicated because you're like, well, nothing happened. Yeah, it's like we didn't really do anything. Right, because I made x equal t. Okay, this one, I made t equal the derivative. All right, so t equals the derivative of this. So what is the derivative of this? Negative 2x. I know, like once you've done both, you have to switch gears in your head. So divide by negative 2. You get negative t over 2 equals x. The 20th. And then you're going to take this and plug it in for x. So you would get 1 minus negative t over 2 squared. So that would be 1 minus, what, t squared over 4? Oh, and I'm sorry, I should have written this over here. X was negative t over 2.